So we're looking today at shells and orbitals. S orbitals are spherical. P orbitals have this dumbbell shape, and at the lowest energy level we have a 1s orbital in the first energy level. It has a principal quantum number of 1 and it's an s orbital. Then we have a 2s orbital. This is a slightly higher energy here. It's got a principal quantum number of 2 and it's an s orbital. Within this same shell, we also have a 2p orbital. Now it's in the second energy level, it's in the second shell, so we give it a principal quantum number of 2, but it's p orbitals, 1, 2, 3 p orbitals, and it makes up the 2p subshell. So we want to look at how we fill our shells. Think about how people sit on a bus. When they get onto a bus, they will, even though there's lots of empty seats around here, invariably they will make sure that they're not sat next to someone else. So the first thing they will do is sit separately on the bus, and only when there's not any double seats left, unless they're there with a friend, only then will they start to fill up these empty seats here. So I'm going to call this the bus seat rule. It's the same with electrons filling up orbitals, subshells and shells. Electrons do not like to be paired with something unless they have to be. Now this pairing that I'm talking about, electrons have something called spin, and you don't need to worry about what that is for the moment, but electrons within an orbital will have opposite spins. We represent that by having one electron pointing up and one electron pointing down. And you can see here that in each of these orbitals, within each of these subshells, within each of these shells, there are 2 electrons in each orbital. But when we've got to here, and don't worry about why I've filled this up yet before the 3D, but when we've got to the 3D shell, subshell, I'm filling each orbital with 1 electron before I start to pair them up. Only if I come along with another electron here that wants to go into an orbital, only then will I start to pair it up with another one, just like the seats on the bus. So we'll talk about how we fill the shells. First of all, we fill from the bottom up in increasing energy, and we try and keep electrons single in each orbital wherever possible, but they can hold up to a maximum of 2. So just have a look at the electronic configurations on the right. Pause if you want to, but you can see that we're filling from the lowest energy upwards, and our electronic configuration tells you which orbitals are filled and what with. So 1s2, 2s with 2 electrons, and so on, 2p, 6 electrons. And now we're going 3s2, 3p1, 3p2, and so on. And just a little bit of a jump here. Just watch, at the moment we've got the 4s2. Now that's filled before the 3D. We'll talk about that later. And again, we're filling singly. But now with a 3D, we're filling singly until we have to start doubling up again. Again, something odd is going to happen with copper. So you can see here a representation of the orbitals and shells in a fluorine atom. It's not quite complete yet. When you fill the electron shells, orbitals in an atom, you start from the lowest energy levels. I've filled up the 1s shell with 2 electrons. So next I have to go to the next energy level, and the next orbital is the 2s orbital. It's in the second shell, that's my principal quantum number, it's an s orbital and it contains 2 electrons. Now fluorine has 9 electrons in it altogether. It has an atomic number of 9, it's got 9 protons, so therefore it's going to have 9 electrons. So far I've only used 8 of my electrons here, and you can see that what I first started to do was fill up different p orbitals within this p subshells, because electrons don't like to be paired unless they absolutely have to be. So they've started off going in their own separate orbitals. I've had to start pairing for my 8th electron, and I have to do that for the 9th electron too. So my fluorine atom has an electron configuration of 1s2, 2s2, 2p5.